In this video, we're going to add two final functions. One to display numbers, and another to display numbers or text in a particular location. You may be thinking that we can already display numbers just by sending a string to the LCD with the string and the quotes with the number inside, let's say 145. And that's pretty simple. You can just display the string of 145 on the display and it'll display. But if the number that we wanted to display on the LCD was from a variable, let's say the variable is called, it's an integer, let's call it a number. And this integer, this variable, obviously, the variable itself can change. That's why it's called a variable. And if we wanted that number to be displayed on the LCD, we first have to convert that number into a string. So we can use this command to send it to the LCD. So how do we do this? There are two main conversion functions that are available for the AVR. One is called ITOA, and the other one is called DTOSTRF. The ITOA is converting an integer to a string, and it accepts the integer, call that value, the character, or the string, which is a character array, and the base, which is, you can actually have this into a string in the format of a binary number, base 10, which is just a standard number that we're familiar with, and base 16, which is hexadecimal. And to represent it for base 10, which is the standard notation we use in daily life, you just put a 10 in there. For hexadecimal, you'd put a 16, and binary is 2. The other conversion function is D, which is double to string, and it accepts a few arguments as well. Just like this one, the first argument is value. The next is the width, and this is the width of the entire number. Let's say we have a double number, 123.45. And there could be a negative or not a negative here. The width of this number would be 1, 2, 3, 4, 5, 6, 7. So that would be a 7-digit number, which includes the negative sign. The next argument is precision. And that's just the number of decimal places after the point. And the last one is the character array, where the number will be stored in the string. You might be wondering, for some of you, what double means. The double is a double precision number, and it has the capacity of a 64-bit binary number. With this capacity, these numbers can get really, really high and have a decimal place, whereas the integer can also be a very high number, but it cannot use the decimal. Integers would always end at the decimal place. I'm also including the setting of the cursor location in this particular tutorial because it's really helpful to be able to set the cursor location every time you show a variable like this number here, so you can show this number in the same location every time it changes. Setting the cursor position is actually quite simple. We'll represent our LCD as 4 lines. This particular LCD we're using is a 4-line LCD. 1, 2, 3, and 4. And then it has 20 characters going across. 1, 2, 6, 16, 17, and that's 20. Each of these rectangles that make up the LCD contains actually a number. And there's a command in the LCD that we can use, send a command function. The actual command is represented as in binary, starting with a 1, 0, 0, 0, 0, 0, 0, 0. So this 1 in the 8th place allows you to access these specific locations on the display. The remainder, or the remaining zeros here, can be a number, and that number will represent which rectangle you're going to be setting the location for your cursor. Because there are so many varieties of LCD, these numbers are not going to be as easy as like say 0 through 20, then this will be 21 through 40, 41 through whatever. it won't be as easy as that, because there are displays with more rectangles across on one line or fewer rectangles. So we will need to find out what the numbers are for our particular LCD. You can do that by actually running a program and displaying a number, let's say on the bottom right hand side, and running sort of an X throughout the entire set, and the number will tell you what number that is. That will be actually our first project. But I'm going to go ahead and tell you what these numbers are anyway before we start. And this is actually the 0 location. So this is 0. And this number represents this particular location. At the end of this line is 19. So since we're indexing from 0, there are 20 locations. The next line is 64. And this shows you how each line can jump from one number to the other just because of the large variety of LCDs out there. And 83 is the end here, which is 20 digits or 20 locations. And on the third line is 20. At the end of the third line is 39. And the fourth line is 84. And at the end of the fourth line is 103. Now you'll notice that going from 0 to 19, it jumps to the third line, 20 to 39. But then from 39, it jumps all the way to 64 for the second line, and then 83, and then it goes on to 84 to the next line, to 103. Now, you'll notice that if you convert 1, 2, 3, 4, 5, 6, 7 digits of a binary number, the maximum number you can have is 128 different numbers. So any LCD that is using the particular integrated circuit that this is using, which is actually pretty standard, you probably never have more than 128 locations on a particular display. So what we're going to do is create another function or routine that allows us to go to any position on this display, and we'll call that GoTo location. And in that GoTo location, we'll have an X and Y value, so we can inform the program where we want to locate the cursor on this display. So X is just going to be a number plus a Y number. The Y, we're going to store these numbers. We're going to store the 0, the 64, the 20, and the 84. We can store this in an array, or we can store this in separate variables, or we can even create a define statement at the beginning of our program that has these numbers, and we can change these depending on our LCD that we use. If we store it into an array, it'll be easier to use it with a Y location. So the array could be an array of 4 different positions, and we just add X to it, because if we say like 64 and we want the location to be here, we would just add this number of positions to 64. So this would be 65, 66, 67, 68, 69, and 70. If X was 1, 2, 3, 4, 5, 6, 7. And the entire process of sending this particular command to the LCD only takes 37 microseconds. So this is a pretty quick way of doing it. A good demonstration of how to put numbers on the LCD and to show you the locations of an LCD, we're going to cycle through all of the positions on the LCD. We're going to put an X in each position. We're also going to erase that X as it goes, so it looks like the X is moving from one position to the other. And on the bottom right, we'll show the actual position as a number, and we'll show that number around here somewhere. We first need to know where this number is going to go. So we know this is 103, so we need we would need a maximum of 3 spaces for this number to go into. But I don't want to use the last space, because I want to know where this X is going, or this position is when an X actually arrives there. So I'll probably select a position around here somewhere. So this is 103, 102, 101, 100, 99, 98, 97. Let's use 97 as the spot for our number, and we'll use 3 spaces for that. Let's write a 97 there so we don't forget. And as the X goes through all of the positions, this number will change according to where the X is located. This will show you, if you're using a different LCD, you can find out the actual numbers of the positions of the LCD. After we do this, we will write some routines so you can send a command of go to location X and Y. Okay, in the program, we're using the same program we had before from the previous tutorial of creating strings for the LCD. You can see that we have the standard include files. We have our define statements for where the LCD is connected to in the circuit to the microcontroller. We have the prototypes that are used to inform the compiler that we have the actual code down here. And we have the main, which is it essentially sets up the LCD, clearing the screen, setting it to 8-bit, and turning it on with the cursor. So what we're going to do now is we're going to show the number of where the current cursor location is on the screen. We're going to cycle through it. We're going to loop through all of the locations on the display, but we're going to go even outside of the realm of our display. We're going to do all 128 locations that is possible, so we see where our LCD will fall, what range it'll fall into within that LCD, or within that 128 possible positions. So where in the program should we actually set up the looping through all of the 128 positions on the screen? We could do it actually outside of the never-ending loop, or we can do it inside the never-ending loop if you wanted to keep cycling over and over again. I'm actually electing to put it within the never-ending loop, so in case I miss the first cycle or the first round of going through all of the 128 positions, I will be able to see it again. So let's go ahead and do that. For this loop, I'm going to use a for loop, and the for loop is essentially the for statement, and we have our initialization, our condition, and our increment or decrement. We're using the increment in this case. And then we have where our code block will be. We can essentially select any variable for the initialization and condition and increment. Generally, I just use a single letter variable to do this, and I'm just going to select x for this. So I'm going to initialize using an integer, int x, and you want to give it a default value. I'm just going to say 0, which actually should be the very first position on our LCD. The condition will be as long as x is less than 128, because it's actually 127 would be the last digit, or would be the last number indexing from 0. And then the increment would be x plus plus. So let me put a little bit of pseudocode in here. First, we want to go to the location, or set the current location. We want to, let's make this a comment. Let's say number 1. Number 2, we would like to put an x at that location. And next, we would like to display the number of that location, display the actual location on the LCD at the bottom right of the LCD. We actually had a number for that. It was 97, and we're displaying this as a number. We'll also have to add a delay when we're going from position to position. Otherwise it would be way too fast and we wouldn't be able to see the X going across the screen, and the numbers would just be a blur. And finally, we would want to go back to the position that was where the X was placed and put a space there so the X disappears and the next X can be shown. Let's go ahead and set the current location. We'll use our send a command function, and we'll use the binary number that represents the initial position on the LCD, and we'll just add the X to it so it walks through each position using the for loop that we've established. Alternatively, we could have used 0x80 instead of the binary number. We can use either one. I'll stick with 80. Let's put the semicolon in here. The next line will be put an X in that location. So all we're going to do is send a command. Actually, send a string. We can do a string, or we can even do a character if we wanted to. We'll do a string in this case. Let's put X here. Now we're going to display the number on the LCD, and we're going to use the ITOA integer converting to a string command. ITOA. Number 3 is going to have a few commands actually. So we're going to take the X is the value. We're going to put it into a variable. So we don't know what that variable is yet. Let's go ahead and make it up now. Let's call it position number, or position string. And then this is going to be in base 10 so we can understand it as humans. The next one we're going to do is actually go to that the location that we've specified in the bottom right, and that was 97. So send a command, and this is going to be 0x80 like we had, and we're going to say plus 97 because we want it at the 97th position on the LCD, and then we're going to send the string of the number. Okay, now we don't actually have a string yet declared. We need to declare this string. If we don't declare it, we can't just put a word in here and expect it to do something. We have to actually declare a string to be used for storing the integer as a string. So let's go over here because we don't want it to continually declaring the string in this loop. We want to declare it outside of the loop only once, and it'll just use it in this loop. So it's going to be a car. We have two options to do this. We can do it with a pointer, or we can do it as an array. In this particular case, we'll do it as an array position string, and we'll give it four characters long. We know we're not going to have one that's 4 characters, but I like to just be safe. Put a semicolon after it. Now we're going to add a delay to slow it down, and I'm going to put probably a 50 millisecond delay. Okay, and then we're going to go back to the location and put a space there. So we're going to take this that we had before, and we're going to, well, let me do it one at a time because I don't want to remove these comments here. And all this is doing is erasing the X that was there before, so we can see the X moving along on the LCD. There's one thing that we need to do before we can run this, and that is the ITOA isn't a command that is generally known with these include libraries. We need to add another library, and that one is called the standard library, and that's abbreviated stdlib.h. And this is actually a library that you would find in C++ or C for a lot of general commands, general functions. And the ITOA is a function that was made in the that is included in the AVR set of libraries. And sometimes you'll find these libraries or these functions are optimized or programmed so it uses less overhead for the microcontroller. So believe it or not, this is all you need to do to have a number put on the LCD and have the positions known throughout the range of the LCD positions. And the next thing we'll do is actually put something a little bit more simple than saying send a command and putting X. We want to have a command that says go to location and have an X and a Y component to that, so it's a lot easier to find locations on the fly. I'm going to do a make all and do a program. So I've programmed the microcontroller. Let's go ahead and plug it in and see what happens. Okay, it looks like it's doing what we expect it to do. The X is going through each position, and the position is being displayed in the lower right hand corner. It'll go through all of the positions. You could note which numbers are starting and ending for each row. We're going to be using the beginning numbers in our GoTo location routine. So let's go ahead and do that now. I already know what my numbers are, and it's 0 is in the first one, 64 is the next position, 20 is the third row, and then 84 is the last row. Okay, to add another command or add another routine, we know that we have to create a prototype and then create the actual routine with the code in it. Let's start with the prototype, and the one that we were thinking about doing was go to location. We could call it go to LCD location or whatever, just so it's more distinct or explains what it's really doing. We'll do go to Mr. LCD's location. This is Mr. LCD, and then we'll have an X component and a Y component. And the X and Y components are going to be really small numbers, so I'm just going to use. We could use a car actually to do this, but I'm going to use a UINT 8_t. This is a 8-bit integer number, and we'll use X for the first one, and we'll do the same thing with the Y. UINT 8t for the Y. Now we're going to take this and create the actual, we're going to do a copy and paste, and we'll send it to the bottom here. And we'll create our code block, And what we need to put in this code block is just sending a command of the position that we would like. But there's something else that we need to do before we get into this, and we need to set the initial row locations in an array. So we'll go over here and we'll create a new array. I'm putting it just under the define because it's sort of like a kind of an initialization statements. We're going to use the int for this one. Integer, actually let's use char on this one. We're going to use char because it's a smaller number than the integer. We don't really need to waste that much space. So let's use char and we'll say we'll call it first column positions. And we'll actually make it say for Mr. LCD. And the reason why I'm doing this and making these variables so long is because we're actually going to put this all in another file, which is going to be our LCD library. And we don't want anything conflicting with our existing variables. So we need to make this a 4-position array, and we can actually populate this array right at the initialization. So we're going to use the equal sign, and to populate the array we're going to use the brackets like we did before. In the code blocks we're just going to put numbers in here. So the first number was 0, which is the very first position. The next row is 64 for the first column. The next row is 20, which is the third row, and then the fourth row is 84. So now we know that if we call up 1, we would get a 0. If we called up 3 in these brackets, we would get a 20. If we called 2 in these brackets, we get a 64. If we called, let's say, 4, we would get a number 84. So if y is equal to 1, then we would get a 0. If y is equal to 2, then we get a 64. If y is equal to 3, we get a 20. And if y equals 4, we would get an 84. So let's go ahead and put that into the code block that we established here. Actually, let me go back and get the very long variable. And we know that if we put y in the brackets, we'll get that number. So we have y being passed in. We'll do that. And first we need to send a command. So let's go ahead and create that. And we're sending a command to the LCD, and we are going to put in this, and then we're going to add x to it. And this will give us the exact location we're looking for. Just by saying go to Mr. LCD's location, we give an x and y coordinate. Sending this command will send it to that position, and we can start writing strings or characters into that position. So that's all we need to put in to this routine. It's a very, very short routine. So we can actually test out or test to see how this works in this particular loop, but we're not going to be going through the entire 128. For x, we're going to go only to 20, and we need a y component. So what we're going to do, actually we're going to do this, we're going to have the y for loop on the outside of the x for loop, because we want it to go along each row at a time. So it'll go across the first row, then it'll go across the second row, across the third row. So we're nesting the for x loop within the for y loop. So we need to initialize, let's get this bracket a little closer. Initialize the y, and we're going to say it's equal to 0. And then y is going to be less than 4 because there's only 4 lines. And then we're going to make y increment. We're going to give it this code block. We'll indent this so it looks a little bit more formatted. And we're going to change the sender commands to GoTo location. What did we call it again? Let's see, go to Mr. LCD's location. So let's put that in there. And we have an x and y component instead. So we have x and then y. Let's do the same thing to the rest of them. We have it here, so we can just go ahead and place this one. And we also have one here, but this is at a single location. So we don't want the x and y in there. We want to set an actual number. So we know that the y needs to be on the 4th row, and the x was 97. I'm just gonna pick number 15 actually. 15th column on that row. So we'll go ahead and use 15. That should be enough, far enough to the right. We have 5 characters left on the right hand side. Let's take a last look and see if there's anything wrong. This one here, first column. And we have go to Mr. LCD's location, send a command, first column, and it looks like I have, these should be in brackets actually. I should have not put them in parentheses. Another thing we forgot to do here is to put in the 0x80 plus the first column in Y and then plus the X. There's one other thing that I know that I need to change, because if we are indexing from 0 on the first column position, this is actually 4 positions, but it indexes from 0, and this would be the 0, start at 0, 1, 2, and 3 instead of 1, 2, 3, and 4. So we want to make sure that we're using the right number in this location here, and we can see that we have 4 here, and we're going to change it to 3 because the third column would actually be the last column if it's indexing from 0. So the X or the Y would have a range between 0 and 3, the 0 being the first column, and then the X would be a range from 0 to 19, which would have 20 positions. If we wanted to make it so it actually works the way that we would understand it a little bit better, meaning that the first row would be 1, the second row would be 2, the third row would be 3, and the fourth row would be 4, we would have to go into the Mr. LCD's location routine, and we would have to say right here Y minus 1, because if we would have 4 in here, we would actually have to state the 4 but turn it into a 3, so we would subtract a 1 from it. We'd do the same thing with the X. But let's contain this within parentheses. We don't need this space because we're not going to do any calculations before this. So now we have to actually change the loops. So we initialize this at 1, and we could say if Y is less than 5 now, or Y is less than or equal to 4. We could do it that way too. We can do the same thing with this one. X is less than or equal to 20, and we can change this to a 1, so it starts with 1, the first column, not the 0th column. And now we would have to change this back to 4, so it would actually be on the 4th row like we would expect it to be. So let's go ahead and make all and program the microcontroller and see if it works. Okay, so the microcontroller has been programmed. Let's plug it in and see if it works. And it looks like it does. The X's are going on the first row, and when it gets done with the first row, it actually goes to the second row, which is what we'd normally expect. But you can also see that the numbers are still not being erased, which we never really put anything in there. You can see that it needed to erase that 0 at the end. So let's go. You know what we could do is actually make this more realistic and actually state the Y component and the X component, and we can even say Y equals then the number, then X equals the number. Okay, so let's before we get into putting the Y equals and the X equals, I'm going to clean this up a little bit. I'm actually going to take out the pseudocode that I put in before. And to make it a little bit more readable, we're going to separate this. We're going to put a few spaces in here. Okay, so this is where it creates the X. This is where it, let's separate this out. It converts the number to a string, and it finds a location on the LCD to put it on there. And then it sends sends the number as a string to the LCD. I'm going to relocate these 3 above putting the X, because we can put the numbers on the display anytime we want. This will also have the added effect of putting the cursor actually on the X instead of having the cursor at the number, because we're delaying it here, and we're delaying it where the last thing happened. So that would be the X, and then there will be a little cursor after the X, so we know where the cursor is actually located. Okay, so we can, we know the position string, we know this is X. Here, we're going to make 2 of these. One is for X and one is for Y. So we'll put the X first. We're going to copy and paste this and put the Y here. We'll just change this to Y. We can keep the same character string because we're just going to be overwriting what we had here and just putting it here. And we've already put it to the LCD, so we don't need that string anymore. So we can write something else over it. So we have that, and we also want the x equals something. So we're going to send another string right before it, and we're just going to add in a string that says x equals, and we'll put a space after that so it has a nice space. We'll make it uppercase X so it doesn't look like the X that we have running around on the screen. We'll do the same thing for Y. Now one thing we're going to run into is the 15 may not be enough space, or may not be enough space at the end of the LCD. The other thing is we want this to disappear after it's created, just like the X is disappearing. We don't want the numbers to contain any artifacts when it goes back to, like, say 1 to a single digit. So let's go ahead and copy both of these, and we're going to put it after the disappearing of the X, and we're just going to, we don't actually need to do 2 strings, we can do this, and we're just going to add spaces in here. X space equals space, and then 2 digits. So this is about how much space we will need. And let's count the number of spaces so we know that 15 is a good number. 1, 2, 3, 4, 5, 6. So 15 would actually be a little bit high, so I'm going to make this a 12 just to give us a little bit of room, and we'll do that to the one above as well. The next thing we need to do is change the Y location for the X and Y. So let's make this on the 3rd row, and put this one on the 3rd row because we're erasing the X there. So we don't want these to be on the same row because one would just write over the other. Okay, so let's go ahead and make and program, and we'll see what we have. Okay, the microcontroller has been programmed. Let's plug it in and see what happens. Okay, so you can see that we have X equals and then the number where the position is for X. The Y equals 1. When the X goes to the next line, we'll see the Y equals 2. And it looks like it's working correctly. You will also notice that the cursor is following the X. The cursor is just after the X. And that's because we have that as the last thing we're showing before we do our delay. And then once it's gone through the entire loop, it starts over again because we have this in our never-ending loop, and it'll just do this forever as long as we have this plugged in. The next video we will separate all of the LCD code into its own library so we can access it but not have to look at it. Thanks for watching.